Welcome to Brain Vision.
Okay, here we have a wheel that's rolling to the left, initially at some position x0, has some initial velocity x0 dot or v0, whichever way you prefer to write it there, has some angular position theta, which will change as it rotates, of course, here. So we can, and it'll have some radius r associated with it. We can rewrite the position x0 in terms of theta. Assuming it starts at 0, will just be r times theta. We can differentiate this equation to give us that v0 equals r times our angular velocity, which will just be theta dot. Can differentiate again, of course, to get the acceleration. A0 would equal r theta double dot, or just r alpha, whichever way you prefer to write it is perfectly fine. We can then get our x and y components for the position A here. So for that, the x position is going to be x equals the initial x position minus r times the cosine of theta. The y position will simply be the initial height of r, because that'll put us at the middle of the circle, plus r times the sine of theta. We can differentiate our equations. So we'll get an x dot equals the velocity of that position. So that's x0 dot, or just v0, plus r times theta dot, or omega, whichever way you prefer to write that again, times the sine of theta. Do the exact same thing for y. When we differentiate, when we differentiate y, we end up r, the derivative of r is just 0. So we end up with, fairly simply then, just v0 times the cosine of theta, which would just be r times theta dot. We can rewrite our equation for x dot using what we learned above here, specifically that v0 equals r theta dot. Rewrite this as v0 times 1 plus the sine of theta, just to simplify it a little bit. We know that the total velocity can be found using the Pythagorean theorem. So it'd just be x dot squared plus y dot squared, and then take the square root of all of that. When we put that into the equation and simplify, so we just put our x dot in, square it, and our y dot in and square it, the v0 will come out, and we'll be able to simplify things a decent amount here. Which I'll actually show here. So I pulled the v0s out, but inside the square root, I have a 1 plus sine of theta quantity squared. So I'll give us a 1 plus 2 times the sine of theta squared. Just a 1 plus 2 times the sine of theta. Then plus the sine of theta squared, but then we have a plus a cosine squared of theta. Well, we know that sine squared plus cosine squared is just 1, so this simplifies quite a bit to just v0 times the square root of 2 plus 2 times the sine of theta for our velocity. Now we want to represent our velocities graphically here. So we can do that. If we have our wheel here, we have our angle theta, our position A, we will have our velocity, our resultant velocity here will be up and to the right. We'll have the velocity along the wheel up and to the left a little bit, so that's v0 going that way, and then the velocity, the horizontal velocity to the left, and this will form a rhombus here, and our angle here will just be our 90 minus theta. Now we can do the same thing but get our accelerations. So if we take the derivative of our x dots and our y dot, what we get is x double dot, which is just the x acceleration, v0 is the same. We take the derivative of this 1 plus the sine of theta, which will give us a theta dot times the, so we have a v0 times a theta dot, this time times the cosine of theta, which we can simplify again just a little bit and rewrite this as v0 squared over r times the cosine of theta. We're doing that just to make this v squared over r term that we're used to. We do the same thing for the y, where when we take theta double dot, we end up with a negative v0 squared over r times the sine of theta. We can sketch these again as well, and we'll see if we have the origin there, or the center of this circle. We have theta. We have our x double dot to the right. Sorry, that's not writing well. Let me erase that and rewrite that. X double dot, and we'll have our y double dot down. And we'll see then that we have that same angle theta there, and our resultant acceleration is straight inward. And we can find the magnitude of that acceleration. Well, if one's cosine and the other one's sine, and they have the same factor out front of it, then the magnitude of that acceleration using the Pythagorean theorem will just be that v squared over r, to make our lives nice and simple. And we can actually show that as well real quick here, that the acceleration equals the square root of x double dot squared plus y double dot squared, which will be, we can factor out that v0 squared over r, which are both squared, then we take the square root of it, so that gives us a v0 squared over r times square root of, with the x we had the cosine squared theta, plus the y is the sine squared of theta, which just gives us a 1. Or we're left with v squared over r, And the direction has to be directly inward towards the origin or the center of the circle, which they called point O.